All right, we're going to look at what we covered last week, which is area of quadrilaterals and triangles. Quadrilateral is a four-sided figure. Cuatro from Spanish. Quad bike, four wheels. Quadrilateral, a square, a rectangle. A parallelogram, which is basically a crooked square or rectangle, a diamond, any of those. Area of a quadrilateral, we just multiply this times this. To help you with area of quadrilateral and area of a triangle, I'm just going to call it base times height, even though most books and classes will call it length times width. Okay? But here we'll just say base times height. I can draw this 1, 2, 3, 4, 5 inches across. And it says 4 inches up. I can draw that 1, 2, 3, 4. And if I were to continue those lines, 1, 2, 3, 4, and count, I would count 20 square inches, 20 squares that are 1 inch by 1 inch. Okay? And the shortcut, of course, is just this times this. That's 20 square inches. Here is the same rectangle, but we just want the triangle that has the same base and the same height. So hopefully by now we know that if a rectangle or a quadrilateral is base times height, then a triangle is half of that. Base times height divided by 2, okay? Just half of it, okay? That is review. We should know that. We should have that probably memorized by now, okay? This times that for a quadrilateral, this times that, but half of it for a triangle, because a triangle is always, 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 always half of a quadrilateral, okay? Now, moving on to the new concept, which is volume, 3D objects. These are not 3D objects. These are two-dimensional objects, flat objects. One dimension is side to side. The other dimension is this right here, up and down, okay? Side to side, up and down, 2 dimensions, flat. So when we answer for the area, we put a little 2. Like this would be 10 inches squared. This would be 20 inches squared. Squared, 2 dimensions, because we fill it with squares, like your floor, like a wall, like a window. Flat, we fill it with flat, 2-dimension squares, okay? But for volume, we're looking at 3D objects. 3D objects, okay? So one thing we learned yesterday is if we have the same shape repeating over and over again, if we have the same shape repeating over and over again, we call it a prism, okay? And then we just have to understand what the first shape is. This is a rectangle, so this is a rectangular prism, okay? You can think of this like a warehouse, a storage, something on a train would have a shape like this, and you fill it with things. Containers on a ship. If you're bringing over a bunch of PlayStations from Japan or a bunch of food from somewhere, you put them in these large containers, and you need to know how much space there is inside of those containers. Okay. So 3-dimension, we're talking about volume if it's 3-dimension. How much space is there inside of something that's 3D is volume. Okay? Shane? So the way that we solve for volume is just 2 simple rules. Rule number 1 for volume is find the space of the first shape. Since it's flat, we'll talk about area. Okay? Find the area of the first shape. We already did that. It was 5 times 4 equals 20. Okay? And then ask yourself, how many of those shapes are there? So if I think about it as a loaf of bread, this number will tell me how many slices there are of the same rectangle. So to make it easy, let's say that this is 10 inches. So that tells me that there's 10 of these slices right here, 10 of these rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have to pretend, okay, that there's 10 of them right there, okay? So if the first slice is 20 square inches, if there's 20, and there's 10 of them that are exactly the same, then we find the area of the first shape called the face. That's rule number 1, find the area of the face, okay? And we multiply it times how many there are. Because 10 times, you're going to have 20, okay? 10 times, you're going to have 20. 20 inches, and you can tell these are no longer flat squares. These are now cubes. Okay, 3D. They're cubes. So 20 cubic inches. We put a 3 there for cubed because it has 3 dimensions. Here, here, and then deep. Okay? So 200 inches cubed. Did I say 20? I might have said 20. 200 inches cubed for that. Find the area of the face, multiply times how many there are. Okay? Triangle prism. Okay. I can erase these two things now here. We were just showing that a triangle is half. Okay? A triangle prism, it's a triangle over and over and over again. You can think of it like a tent. Okay? 1, 2, 3, 4, 5, 6. This one will be 7. Okay? And let's do feet instead. We'll pretend this is a tent. We'll do feet. Rule number 1, find the area of the face. Okay? Find the area of the face. Let's see, 5 times 4 is 20, but that would be for the quadrilateral. A triangle is half. So half of 20 is 10. 10 square feet for this triangle. How many are there? 7. 7 triangles stacked together. Okay? So 7 times we have 10 square feet. For a total of 70 feet, but now that we're doing 3 dimensions, we're talking about cubes. You would fill a tent not with flat squares, but with cubes. So 70 feet cubed. Find the area of the face and multiply it times how many there are. That's how we find the volume of 3-dimensional prisms.